am S. Arokia, Assistant Professor, Department of Computer Science, St.Joseph College for Women, Tirupur. Today I am going to explain about Introduction to Case Tools. The topics covered under Introduction to Case Tools are Computer-Aided Software Engineering, Components of Case Tools, Benefits of Case Tools, Data Model and Data Flow Diagram. Computer-Aided System Engineering. Case tools are programs that automate or support one or more phases of a system development lifecycle. There are collection of tools to support software development process used to support software process activities by automating process, providing information about the software being developed. Components of case tools: central repository, diagramming tools, report generator, analysis tools, documentation generator, code generator. Components of case tools: central repository. It is centralized repository used to store graphical diagrams, prototype forms and reports, and act as information repository or dictionary. Report generator: create, modify and test prototypes of computer displays and reports. Identify data items to display or collect for each screen or report. Diagramming tools: represent a system and its components visually. Higher level process to easily decomposed can examine process or data models at high or at low level. Analysis tool: it generates report and identify possible inconsistencies, redundancy and omission. It focuses on diagram completeness and consistency, data structure and usages. Documentation tool: creates standard reports. Highly qualified documentation leads to 80% reduction in system maintenance. Code generation tool: creates code. Code generation tool helps in connect to the repository, select the object model, select the custom features, define properties and specify the output of the project. Benefits of case tools: improve software quality, enforce discipline, helps in communication between development team members. Information is illustrated through diagrams that is easier to understand. Development information is centralized. Reduction of time and effort. Tasks are faster to complete and alter. We can reuse models. The maintenance cost is reduced. There are some problems in case tools: limitation in flexibility of documentation, completeness and syntactic correctness does not mean compliance with requirements, cost associated with the use of the tool, purchase, price and training. Data model. Data model is a collection of conceptual tools for describing data structures and is powerful in expressing and communicating the business requirements, and visualizing represents the nature of data. Data model describes the design of physical and logical view. There are three different types of data model. Types of data model: conceptual, logical and physical. Conceptual model deals with what the system contains. Logical model deals with how the system will be implemented. Physical model leads Physical model deals with the system will be how the system will be implemented using specific DBMS. DFD, that is data flow diagram. It is a graphical tool, performs structural analysis and logical requirement, useful for analyzing existing and proposed system, focus on movement of data. It is a simple technique to learn and use. Elements of DFD: external entity, processes, data stores and data flows. Symbols used in DFD: by Gann and Serson symbol and DeMarco and Jordan symbol. External entities: supply or receive data. Two types are involved: source and sink. Source supply data from the system and sink receive data from the system. Process works inside the system. Incoming arrows are input data flows. Outgoing arrows are output data flows. Process can connect to any other symbol, contains the business logic and also called business rules, referred to as a black box. Data stores. Data store is a repository of data. Data can be read from a data store. Data flows. Data is motion, connects the processes, external entities and data stores. Leveled DFDs. There are three types of levels: level 0, level 1 and level 2. Level 0 is context diagram, level 1 is overview and level 2 is detailed. Level 0 context diagram identifies external entities and related input and outputs. Level 1 overview gives overview of full system, identifies major process and data flows between them, identifies data stores. Level 2 detailed. Level 1 process is expanded into more detail. Each process in level 1 is decomposed. Boundary of level 2 is the level 1 process. Rules for DFD: numbering, labeling and balancing. Numbering: level 1 process are numbered 1, 2, 3. On level 2 process are x.1, x.2, etc. Labeling: process label, data flow label and data store label. Process label is short description of what the process does. Data flow label is noun representing the data flow. Data store label describes the type of data store.